Today we are inside a modern strawberry production factory, following strawberries from a massive farm to a finished dessert cup. The goal is simple and strict. Keep the fruit cold, keep it clean, and keep the texture intact. You will see how thousands of trays are harvested, cooled immediately, and moved through washing, sorting, cutting, cooking, freezing, and assembly. By the end, those fresh red berries become two products at once: a glossy strawberry compote and individually frozen strawberry pieces, both layered into a chilled dessert. Watch closely, because the smallest details, like gentle conveyor speed and surface drying, decide whether strawberries stay bright and firm or turn soft and bruised. We start at an industrial strawberry farm, where rows run long and straight, built for speed and consistency. Workers pick only fully red strawberries and cut the stem cleanly at the right point, so the fruit does not tear. Each strawberry is placed into ventilated, food-grade plastic trays, one layer deep to prevent crushing. Trays stack onto pallets in a stable grid, so weight stays on the tray frames, not on the fruit. This is where quality begins. A strawberry that is squeezed or bruised here will not survive the factory line. The entire harvest moves in a steady rhythm, pallet after pallet, with the day's volume heading straight into a cold chain. Before the strawberries leave the field, the pallets go into rapid cooling. Cold air is pushed through the tray vents so the fruit cools evenly, not just on the outside. This step slows softening and protects color, aroma, and firmness. The goal is to bring the fruit down fast without freezing it. You can see how airflow channels between trays, and why the trays have open sides and bottoms. Cooling is not about comfort. It is about preserving the fruit's structure, so it can be washed and handled without turning into juice. From here, the strawberries move directly into refrigerated transport with the cold chain already established. Logistics is built around one rule: do not break the cold chain. Pallets are moved by forklift along fixed lanes, then loaded into refrigerated trucks. The pallets are strapped tight with plastic bands and stabilized with anti-slip mats so they do not shift during transit. Inside the trailer, air circulates around the pallet stacks instead of being blocked by solid walls of boxes. Every minute matters, because strawberries are delicate. The route is planned, the loading is fast, and the doors stay open for as little time as possible. When the truck pulls out, it is not just carrying fruit. It is carrying temperature control and freshness. At the factory receiving bay, the truck backs into a sealed dock to reduce warm air exposure. Pallets roll onto the receiving floor and pass over a scale for a full lot weight. The batch is identified internally and staged in a chilled buffer zone so the line can feed steadily without the fruit warming up. This buffer area is clean, bright, and organized, with clear traffic flow for forklifts and pallet jacks. Nothing sits here for long. The system is designed so strawberries move forward, in one direction, from raw receiving to clean processing, with no cross traffic. Now the fruit is ready for quality checks before it touches the main line. Quality control begins with sampling from multiple pallets across the lot. Technicians check size, color, and ripeness, and they remove any strawberries that are crushed, leaking, moldy, or underripe. They also inspect for leaf fragments and stem pieces that can ride along in trays. The goal is not perfection. The goal is consistency. A dessert line needs strawberries, that behave the same way in washing, cutting, and cooking. Samples are also taken for internal safety checks, according to the factory's process plan. Once the lot is approved, pallets are released to the in-feed system. From this point on, gentle handling is everything. Strawberries do not forgive rough machines. Trays are tipped onto a soft in-feed conveyor, designed to reduce impact. Instead of dropping fruit hard onto metal, the strawberries roll onto a cushioned belt and spread into a single moving layer. Side rails guide the fruit and prevent piling. The belt speed is deliberately slow because a fast belt creates collisions. You can see the strawberries travel with minimal bouncing, spaced enough so the next systems can wash and inspect each berry. Any leftover, tray fragments, or loose leaves are removed before the wash stage. The goal is a controlled flow, not a chaotic dump. A stable in-feed means cleaner washing, better sorting, and less damaged fruit. Now the strawberries move into the first wash. Wash stage 1 is a gentle water flume with controlled turbulence. Water carries the strawberries forward while lifting dust and field residue away from the surface. Light debris, like leaf pieces, rises and is skimmed off. Heavier particles settle and are removed separately so they do not recirculate. The strawberries then ride up onto a drain conveyor where water falls away through the belt. This is not the final clean yet. It is a first pass that removes the bulk of dirt without bruising the fruit. The flow is steady and the water management is strict, with dirty water separated from the clean side. Next comes a second wash designed for food processing standards. Wash stage 2 focuses on sanitation and final rinsing. The strawberries pass through control style strays that reach all sides as the fruit rotates gently on a belt. A food-grade sanitizing step is applied at a controlled concentration and contact time. Then a clean rinse follows immediately to remove any remaining solution. This stage is carefully balanced. Too harsh and the fruit skin is damaged. Too mild and the process is not effective. After rinsing, the strawberries move onto a draining section where excess water is removed before sorting. Water left on the surface becomes a problem later because it can dilute compote and cause slipping during cutting. That is why drying matters so much. Now the strawberries go through surface drying. First, a squeegee-style blade removes bulk water from the belt. Then filtered air blows across the fruit to dry the skin without warming it. The goal is not to dehydrate the strawberries. The goal is to remove free water, so the next steps are clean and controlled. Drier fruit improves camera sorting accuracy, reduces cross-contamination risk, and keeps compote texture consistent. You can see the berries look brighter as water sheen disappears, and the seeds become more visible. Once the surface is dry, strawberries are ready for optical sorting. This is where automation decides which strawberries become compote and which become premium frozen pieces. Optical sorting uses cameras and lighting to evaluate each strawberry as it passes. The system checks size and color, separating strawberries into groups so downstream machines can run with stable settings. Fruit that is too pale, too dark, or visibly damaged is rejected. The goal is not only appearance. Different ripeness levels cook and freeze differently. A consistent group produces consistent compote texture and consistent frozen bite. After sorting, strawberries move to a stem removal step. Any remaining stem pieces and leaves must be removed before cutting and cooking. This prevents bitterness, improves hygiene, and protects cutting blades. The line stays straight and stable, and the strawberries keep moving without stopping. Stem removal is designed to be gentle. Strawberries pass through a mechanism that grips the stem area lightly and separates leaves and stem fragments without tearing the fruit. Removed stems and leaves drop into a separate waste channel that never crosses back into the clean product flow. This is an important factory rule: waste moves away from product, always. After destemming, the strawberries are ready for cutting. Some will be cut for compote, and some will be kept as whole or large pieces for freezing. Cutting must be precise, because smashed strawberries release juice and lose structure. The goal is clean edges, minimal pressure, and uniform piece size. Now the line prepares for controlled cutting. In the cutting section, strawberries move into alignment channels, so blades meet them consistently. Depending on the dessert design, the fruit may be halved or diced into a uniform size. Stainless steel blades cut quickly with minimal compression, and the pieces fall onto a clean conveyor without piling. The key is uniformity. Diced strawberries must match in size, so they cook evenly for compote and look consistent in the final cup. Any fragments that are too small are separated as a lower grade stream. At this point, the process splits into two parallel lines. One line creates strawberry compote, thick and glossy. The other line creates IQF frozen strawberry pieces that stay separate and do not clump. Here is the split. Line A sends strawberry pieces to compote production, where heat and sugar create a stable dessert layer. Line B sends selected strawberries to IQF freezing, where extremely cold air freezes each piece individually. This dual approach gives the final dessert both flavor and texture. Compote provides rich strawberry taste and color, while IQF pieces add real fruit bite on top. The factory balances both lines, so assembly never runs out of either component. Conveyors, bins, and buffer hoppers keep flow stable. From here, we follow line A first, into compote cooking. You will see how heat is controlled to soften fruit without destroying it, and how sweetness and thickness are measured for consistency. Compote cooking starts in a jacketed kettle, designed for gentle, even heating. Strawberry pieces enter with a measured amount of sugar, and the mixture warms under controlled agitation. The mixer turns slowly to prevent foam, and to keep fruit pieces visible, instead of shredded. A small amount of fruit thickener, often pectin, may be added to reach the target gel-like consistency without turning the compote into jam. Temperature matters. Too hot, and the flavor becomes cooked and dull. Too cool, and the mixture stays watery. The kettle is tuned for a steady rise, so the strawberries soften, release aroma, and keep a bright red color. Once the texture looks right, the compote moves to filtering and adjustment. After cooking, compote passes through a coarse filtration step that removes stem fragments and unwanted fibrous material while keeping strawberry pieces in the product. The goal is a clean, spoonable compote where you can still see fruit. Next, operators verify thickness and sweetness using rapid checks. If the compote is too thin, it will sink into the cream layer and look messy in the cup. If it is too thick, it will not deposit cleanly and can trap air bubbles. The compote is adjusted carefully to hit a consistent target every batch. Then, the line removes excess air. Duration reduces foaming, protects flavor, and improves seal quality later. Now Compote heads into a heat safety step and rapid cooling to lock in freshness. Compote is deteriorated under vacuum to pull out trapped air and foam. Then it passes through a heat treatment section designed for food safety, with precise temperature and holding time. Immediately after, it is cooled quickly through a heat exchanger to protect strawberry aroma and reduce cooked notes. Cooling also brings the compote to the right temperature for depositing into dessert cups. The compote now looks glossy and stable, with visible fruit pieces suspended evenly. While compote is being stabilized, line B is working in parallel on IQF freezing. That is how factories keep throughput high without compromising quality. Next, we move to line B to see how strawberry pieces are frozen individually, so they stay separate, bright, and ready for topping. IQF freezing begins with strawberries in a single layer on a stainless steel mesh belt. The belt enters a freezing tunnel where powerful cold air circulates from multiple angles. This freezes the surface quickly so pieces do not stick to each other. The goal is individual pieces, not a frozen block. If strawberries clump, dosing becomes inaccurate, and the final dessert looks uneven. Inside the tunnel, temperature and airflow are tightly controlled, and belt speed is adjusted to reach the target frozen core. The pieces come out firm, dry on the surface, and still shaped like real fruit. Then the line screens out tiny fragments and controls portion size. This keeps the topping consistent cup after cup. After IQF, frozen strawberry pieces move over vibrating screens that separate crumbs and small fragments. The main pieces continue forward into a dosing system that measures a consistent topping portion. This matters because a dessert cup must look the same every time, and weight must stay within tolerance. Any broken pieces can be redirected to another use, such as compote input, so waste stays low. Now we shift to the dairy side of the dessert, where a vanilla cream base is prepared. This cream base must be smooth, stable, and cold enough to deposit cleanly, without melting the fruit layers. You will see stainless mixing tanks, gentle agitation, and chilled transfer lines that keep the cream at the right temperature for filling. Then we prepare the crunchy layer. Sits under the cream. The cream base is mixed in a stainless steel tank with controlled agitation. Dairy components enter as a pale ivory liquid, and sugar dissolves fully to avoid graininess. Vanilla flavor is added in a measured dose, so it stays consistent. The mixture is homogenized for smooth texture, then cooled to a target filling temperature, so it deposits cleanly and holds a flat surface in the cup. Temperature stability is crucial. Warm cream would melt compote edges and soften crumble too early. Cold cream keeps layers sharp, while cream is chilled and ready. The dessert line also prepares the dry layer, often crumble or small cake bits. This layer adds structure and texture. It must be dry, uniform, and portioned accurately. Now we move to crumble preparation and screening. Crumble enters the line as small golden beige pieces with a controlled size range. It passes through a screening system that removes fine dust and oversized chunks. Dust makes cups look messy and can absorb moisture too fast. Oversized chunks cause uneven filling. After screening, the crumble goes into a dosing hopper that feeds the cup line. The factory aims for a repeatable base layer thickness, so every cup has the same bite. With compote cooled, IQF fruit portioned, cream chilled, and crumble ready, the assembly line can run continuously, cups arrive on a high-speed conveyor, clean, and ready for filling. Now the dessert assembly begins with precise depositing. The line will build the cup in layers, starting with crumble, then cream, then compote, then IQF strawberries on top. Cups move under the first depositor, which drops a measured amount of crumble into the bottom of each cup. The crumble forms an even base layer, not a pile. Next, the cream depositor fills the cup with a pale ivory layer. Multiple nozzles deposit simultaneously, and the flow is controlled to avoid bubbles. The cream settles into a smooth, level surface that prepares the cup for compote. Clean edges matter here. The inside of the cup must stay neat, so the layers look distinct through the clear plastic. This is where factory precision becomes visible to the customer. Now the cups move to the strawberry compote depositor. Compote is thicker and darker red, so it must be deposited cleanly without smearing. Then the line adds the IQF topping for a real fruit finish. The compote depositor adds a glossy red layer, portion by portion, onto the cream. It lands gently and spreads without mixing, creating a clear red on ivory contrast. Immediately after, a topping system drops a measured portion of IQF strawberry pieces onto the surface. Each piece stays separate, with no clumps, because IQF freezing locked the surface quickly. The topping lands evenly across the cup, instead of forming one mound. This makes the dessert look abundant and premium. Now the cups go into a cooling section to stabilize layers and prepare for sealing. Sealing must be tight and clean, but we keep packaging minimal and focus on product integrity. Next, the line checks weight and appearance, then cools the cups, so the final texture holds from the factory to the store shelf. The filled cups pass through rapid checks for fill level and overall appearance. Vision systems confirm that the layers are centered and consistent, and check wires confirm the cup weight stays within tolerance. Then, the cups move into a chilled tunnel or cold room section that stabilizes the dessert structure. Cooling helps the cream set slightly, keeps compote glossy, and prevents moisture migration into the crumble too quickly. The result is a dessert that stays layered and clean when the customer opens it. Now we finish where the process becomes personal tasting. We move to a clean tasting setup, open a cup, and show how the layers behave under a spoon. You will see whether the factory achieved its goal. Bright strawberry flavor, smooth cream, crisp crumble, and real fruit texture. A finished dessert cup is opened cleanly, and the first spoonful lifts through all layers at once. You can see red compote with real strawberry pieces, pale ivory cream that holds its shape, and crumble that still offers texture. The topping strawberries look like fruit, not mush, because IQF kept them separate and firm. This is what modern production is really about: controlling temperature, movement, and time so natural fruit stays beautiful all the way to a ready-to-eat dessert. If you enjoyed this full process tour, hit like, share, and subscribe to Factory Flow. Comment below what you want next: a blueberry dessert line, a mango puree line, or a raspberry factory from farm to finished treat.